In this video, I'm going to go through an example of a linear function. So in this example, I have a variable x, which will be my input, and this takes the values 1, 2, 3, 4, 5, and then my output variable y takes the values 5, 9, 13, 17, and 21. So for each input x, I have an output value y. I can represent these pairs of values on a graph where I have x on the horizontal axis and y on the vertical axis, and each of the green points here represents one of the pairs of x and y values. So for example, the first one, x equals 1, y equals 5, is right here. X equals 1, y equals 5, and that's this first green dot here. And then the second one is x equals 2, y equals 9, and that's this green dot here, and so on. So I've got my 5 data points, and they all lie along a straight line. So when I have data like this that lies along a straight line, I can represent the relationship between x and y using a linear function. And there's two parts of a linear function that we need to think about. One of them is the slope, and the other one is the y-intercept. It's easier to think about the slope first, and the slope is defined as rise over run, which is the change in y. Because y is on the vertical axis, that's how much the graph is either rising or falling. And then the run, that's the horizontal axis, that's the change in x. So to figure out the slope, all I need to do is pick 2 points. Doesn't really matter which 2 points, just any 2 points along the graph. So let's suppose I pick this one, and let's say this one. Okay, so my rise, my change in y, so this point here, my y value is 9, and this point here, my y value is 17. And so the change in y from 9 to 17, if I do 17 minus 9, that will give me the change in y, and that comes to 8. And then the change in x is going from 2 to 4. So my change in x is 4 minus 2, which is 2. 8 divided by 2 is 4. So my slope is 4. And just for practice, try picking any other 2 points along this graph and figure out this rise over run, change in y over change in x, and it doesn't matter which pair of points you pick, you'll always get 4 as the slope, because we have a constant slope in a linear function. Coming on to the y-intercept, that's the value of y when x equals 0. So on our graph, if I extend my graph this way till it crosses the axis, it's asking where on the vertical axis would the graph cross, because that's when x equals 0. So there's a few different ways of calculating this, but one way is to see, in this case, okay, when x was 1, y was 5, and we know that the slope is 4. So each time we increase x by 1, y goes up by 4. So if we decrease x by 1, y ought to go down by 4. So if it goes down by 4 from 5, it must go down to to 1. So the y-intercept in this case must be 1. And then we can put together the slope and the intercept into a formula that represents the equation of this linear function, or this straight line. And the equation is written y equals mx plus b, where m is the slope and b is the y-intercept. So in this case, we've got y equals the slope we calculated was 4, and the y-intercept was 1. So we've got y equals 4x plus 1. And then we can check that this formula does indeed give us our y values for any value of x. So for example, x equals 3. 4 times 3 is 12, plus 1 is 13. Let's just do one more check. Let's do x equals 5. 4 times 5 is 20, plus 1 is 21. So it looks like our formula does indeed create the y values here. So that's a run through of linear functions.